This is a Wilden PX 1500 76mm 3-inch advanced aluminum pump. The liquid chambers are alternately filled and emptied by fluid that is drawn through a common inlet and discharged through a single outlet. The diaphragms in each chamber are linked by a single shaft, allowing them to move in unison. The air valve directs pressurized air to the back of diaphragm A. This begins chamber B's suction stroke, which starts as diaphragm B is moved toward the center of the pump, thereby creating a vacuum in chamber B. Atmospheric pressure then forces fluid into chamber B past the inlet ball valve. When the pressurized diaphragm A reaches the limit of its discharge stroke, the air valve redirects pressurized air to the back of diaphragm B. This begins the discharge stroke of chamber B. The hydraulic forces developed inside of chamber B force the inlet ball onto its seat and the discharge ball off its seat. This condition allows fluid to flow through the pump discharge. The same process occurs in the opposite chamber, constituting one full cycle. The pump will continue to run until inlet air supply is interrupted or discharge pressure rises to equal that of the air inlet pressure.
Okay,
The bottom port. As the diaphragm moves outward, the discharge motion causes the balls to
this is
move
the
away
same
from
pump,
each other.
basically.
World, with a smart, simple design perfected during years of intensive research, the A200 combines rugged reliability and ease of maintenance to deliver the best performance on the market today. The A200 is engineered to outperform the competition while using the fewest number of air valve parts in the industry. In fact, during operation, only 4 pieces of the air valve move. This makes the A200 easier to maintain, faster to fix if there's a problem, and less expensive to operate overall. Here's a look at what makes the A200 tick. Check valve.
This pump is what's used, this type air pumps is more commonly used. The biggest killer is right there, that air valve is trash and dirty air, water in your air, anything like that, and cold weather. It's got a little water, if you're gonna have water, you compress air, unless you got dryers, have dryers. And, if you get a little moisture in there and it gets cold, it'll freeze up, frost up, and it'll lock that valve down. So, some common troubleshooting on one of these air pumps is usually that air valve is failed, it's just not operating at all. You can have one of these ball check valves, get a trash in it, and it'll be stuck open, that'll cause it not to operate, or one side to operate, and the other side won't, and it'll just stop the flow, or decrease the flow. So these air pumps, I got a feeling you're gonna see them, 1 or 2 out there, not many.
Diaphragms. The diaphragm rod assembly, the main air valve, and the pilot air valve. Now that you know the key components of the A200, we can discuss how it works. 2 diaphragms connected by the diaphragm rod work in unison to create the liquid motion of the pump. While one side is in suction mode, the other is in discharge mode. As a diaphragm moves inward, it creates suction. This suction motion causes the balls to move towards each other. As this happens, the top valve closes and the bottom valve opens. This allows liquid to enter the chamber through the bottom port. As the diaphragm moves outward, the discharge motion causes the balls to move away from each other. As this happens, the top valve opens and the bottom valve closes. This allows liquid to exit the chambers and discharge through the top port. This process constantly alternates between the 2 chambers to create a continuous cycle. The pump diaphragms are driven by pressurized air that is directed left and right by the movement of the main air valve. Here's how it works. When air pressure is applied to the pump, the main air valve moves up and down. When the main air valve is in the down position, air pressure is diverted to the right diaphragm. At the the same time, exhaust air from the left diaphragm passes through the shuttle and shuttle plate and exits the rear of the pump. When the main air valve is in the up position, air pressure is diverted to the left diaphragm, while the right diaphragm is exhausted. This process constantly alternates between the up and down position to create a continuous cycle. The pilot air valve directs the air that moves the main air valve. It is constructed of 5 separate chambers and a central rod that moves side to side due to the diaphragm pressurizations. The pilot and main air valves work together to drive the pump. The pilot air valve has 2 logical states, which we will call left and right. Pressurized air enters chamber 3 in the middle of the pilot valve sleeve. Chamber 3 is always under pressure. When the pilot air valve travels far enough to the right, chambers 3 and 4 are connected. This allows the pressurized air from chamber 3 to pass through and exit chamber 4, which moves the main air valves upward. This causes the left diaphragm to pressurize and the pilot valve to begin moving left. When the pilot air valve travels far enough to the left, chamber 3 connects to chamber 2 and the air moves the main air valve downward. This causes the right diaphragm to pressurize and the pilot valve to begin moving right. Throughout the cycle, one side pressurizes as the other exhausts. This process constantly alternates between the pilot and main air valve to create a continuous cycle. The simple, straightforward design of the All-Flow A200 allows the air and liquid ends to work together reliably to transfer your process fluid in the most efficient manner possible. Put the All-Flow A200 to the test and experience the difference for yourself. Visit www.allflow.com today to find an All-Flow distributor near you.
Okay. And I think we can come back to this centrifugal pump last. But we're gonna talk about it more. This is a gear pump.
Gear pump.
Oh.
Cannot understand.
Yeah, he can't understand him. Yeah, I've had trouble finding.
Guinea, whatever thing is, Guinea.
Indian accent. It's an Indian accent.
I think his name's Guinea or something like
Gear pump is shown. One of the gears, driver gear, receives drive from a prime mover.
Okay, it's a driver gear. This is the driver gear pump. That's where you,
that. I like that driving gear.
this is where the motor will be attached to the drive gear. This drive gear will actually turn the other gear. And this pump is tolerance sensitive. It's got a real close tolerance on the inside of the pump between the gears and the casing and the housing. Just a small amount of wear on the gauge pressure of this pump. It can go from a 250 PSI pump to a 70 PSI pump with just a scratch in the. So when you go to troubleshoot one of these pumps, usually they're small. You don't see them real big. When they get big, they call them a load pump, but they're very small to use for chemical. They're basically a throwaway pump. So we'll let him go on, and something you can't understand, tell me, and I'll stop.
Driver gear, in turn, transmits motion to the driven gear. In its working, gears unmesh at suction side. Liquid is carried between the teeth.
This was a question asked earlier. When the fluid comes in, it has to travel around each gear. You see the arrow? Between the gear and the casing and the outlet. It will not travel. If you see, there's no clearance right there for it to travel through. between the gears. That's a lot of, I've had mechanics come in and tell me they'd have a pump with pump, and go out there and come find out the rotation was wrong on pump. And because they would think that the fluid was supposed to go between the gears, but it's not. It goes on the outside in these cavities between the gears and the casing. And that causes pressure. Because the fluid can't reverse back between the gears here, that gear pump will create a high pressure. Not a lot of volume, but a lot of pressure.
And casing, the gears come back to mesh and forces the liquid out.
You see the rotation? It looks like it's backwards. When somebody looks at it, they'll say, it's rotating backwards. But it's not.
The description is a simplified extract from the positive displacement pump training course developed by Yesian Graphitek.
So you
The
got
actual
fluid.
tutorial covers a large variety of pumps and provides much.
Mr. Orton, you got fluid in the top housing and the bottom housing?
Yeah,
Okay.
fluid all, top and bottom. And this is
Is that just for the gear type?
just
You're gonna have the top and the bottom, the gear? pump?
basically, there's other pumps like load pumps, stuff like that, we're not gonna cover load pumps, but, that basically work the same way.
So the top housing will be pulling the fluid, where the bottom housing will be pushing the fluid. Is that correct?
Both
Looks
of
like
them,
they
both
both
of them.
pull.
Both of them are
Both of
working,
them are pushing it.
yeah, they're both working together, they turn in opposite directions, but they're working together.
They're doing the same motion then, okay.
Yeah, see. I'm
Kind of
starting
like a
to
gravity thing, maybe?
Yeah, that's
See,
what I
it's
said.
turning. They turn in opposite directions, but.
One's pulling over the top.
That's what I'm
one's
saying,
pulling
one's
underneath.
pulling, one's pushing.
Bottom, yeah.
They're both pulling, one's pulling down, one's
The
pulling up.
description
Yeah,
is
but
a
one's
simplified
pulling up to push and one's pulling down to push. It's the same difference.
Same thing.
This is my redneck lingo, I'm sorry.
But when you see they talk about positive displacement pump, that speaks for itself. It's positively needs to be displaced. I mean, so some pumps can be regulated on the discharge. You can, have a flow valve or a float valve or whatever, regulate the flow as it goes out. It don't hurt the pump. Centrifugal pump is one of those pumps, but a positive displacement pump, if you put it in 10 gallons a minute, it needs 10 gallons a minute needs to be going out on the other side.
So it's proportional on both sides.
Extract from the positive displacement pump training course developed by Yesian Graphitek. The actual tutorial and much more details with a large amount of interactivity. For more details, visit yesian.com.
Okay, I got two, centrifugal pump.
There's a better way to see and manage your people, projects, and profitability. Financial Force Professional Service.
Hi, good morning and welcome back. Today let's learn the working of a centrifugal pump with this animation over here. So this is the centrifugal pump over here and let's see the
One
fluid
second,
flow.
Bob.
The arrow shows the fluid.
Speaking like up the road.
This one might.
Speaking like up the road.
Centrifugal pumps are the most preferred pumping devices in the hydraulic world. In this video, we will have a conceptual overview of working of centrifugal pumps.
Centrifugal, centrifugal,
At the heart of the system lies the impeller. It has got a series of curved vanes fitted inside shroud plates. The impeller is always immersed in water. When the impeller is made to rotate, it makes the fluid surrounding it also rotate. This imparts centrifugal force to water particles, and the water moves radially out. Since rotational mechanical energy is transferred to the fluid, at discharge sides of impeller, both pressure and kinetic energy of water will rise. At suction side, water is getting displaced, so a negative pressure will be induced at I. Such low pressure helps in sucking fresh water stream into the system again, and this process continues. This is the reason why priming is important for centrifugal pumps. If no water is present initially, the negative pressure developed by rotating air impeller is fitted inside a casing. So the water moving out will be collected inside it and will move in the same direction of rotation of impeller to the discharge nozzle. Here you can note one specialty of casing. It has got increasing area along the flow direction.
You notice the shape of that
Increasing
casing?
area will help.
It's not built like that to be pretty and stylish. It's, the reason is, it starts off smaller and gets bigger. There's a reason for that. And I don't think it explained it in the video too much. Your condition of the housing is very important too. A lot of times I've seen cases where a pump will quit pumping and the guys will go out and change the impeller and run it, everything's running good, and couldn't understand why it's not pumping the volume it's supposed to. Well, come to find out, housing will be wore. And there's a part in the, inside the housing right here, and maybe we'll show it better, but I'll stop it there. It's called like the cut water. It's a part in the housing that's built, and when the fluid comes over, it's just a little lip sticking out inside the housing, catches the fluid and sends it out to discharge. Well, if it wears off that much, the fluid's gonna go round and round in the pump before it comes out. So you're just gonna lose the flow.
It's called what now?
Cut water.
Accommodating the newly added water stream and will also help in reducing exit flow velocity. Reduction in flow velocity will result in increased back pressure, which is required to overcome the pumping system. Here you can see more details of vanes inside impeller. They are backward curved vanes with state-of-the-art eye configuration. This vane is extracted from a Kirloskar pump model. If pressure at suction side of impeller goes below vapor pressure of water, a dangerous phenomenon could happen. Water will start to boil, forming vapor bubbles and spoil impeller materials over time.
Okay. And if we was doing hands-on, if you go to the mechanical part, we're gonna do hands-on, and we're gonna actually start a pump up and show you this phenomenon, which I don't think it's a phenomenon, I think it's just something happened. It changes the sound of the pump, so when you troubleshoot the pump, and, you know, the mechanics out at the plant, and myself, we learned over the years, you can walk up to one and listen to it, and 90% of the time, you knew what was wrong with it. And especially cavitation, because it sounded like somebody threw a bucket full of rock or marbles in it. All right, and you have a cavitation sound, which that's what they're calling this, cavitation. And then you could have a closed discharge sound, where somebody has closed the valve on the discharge or plug, two different sounds, or a lack of suction sound. There's three different sounds that you can get familiar with to troubleshoot the pump. They don't really tell you that here. Cavitation is one of them, and that's when air entrainment, air has been introduced into the suction of the pump, or air entrainment. And it explains to you what it does.
This phenomenon is known as cavitation. More the suction head, lesser should be the pressure at suction side to lift water. This fact puts a limit to maximum suction head a pump can have. Careful pump selection is required to avoid problem of cavitation. Current impeller type is enclosed. Semi-open and open impellers are also in use depending upon application. If the working fluid is cloggy in nature, it is preferred to use open kind of impeller.
Clay slurry, we use these impellers throughout the plant in general, but we had the mine was 6 miles away from the plant, and we had these, they weren't monster pumps, but they were high-speed pumps, 3,600 RPM pumps. You had the enclosed impeller in that because it had to push that slurry 6 miles down a 12-inch pipeline. So that's kind of the difference in the use of the impeller. I think it was like 70% solids that went through these pumps, but it could have been up to 80% solid that goes through these. So it makes a world of difference.
But they are slightly less efficient.
And engineers should have that
Mechanical
correct. when
design
you
of
go.
centrifugal pump is always challenging. A shaft is used to connect between the impeller and motor. Since water pressure inside casing is huge, a proper sealing arrangement is imperative in arresting water leakage through shaft casing clearance. Mechanical seal or stuffing box based mechanism is used.
Okay, you saw what, let's see.
It's through shaft casing clearance.
Packing. Okay, you got the shaft is going through the pump, connected to the impeller. You got a pipe over here, full of suction and discharge. Well, you got this area right here for the shaft to dig in, and you're gonna have leakage, or can have leakage, you will have leakage before it's over with. You have to seal that. So, one preferred is a packing, another one is a mechanical seal. Usually used, cleaner products and everything, we use them out at the plant on Kaolin in situations to where it was critical that if you had like an 80% solid slurry going in the pump, needs to stay 80% at the end. Because when you use packing, you have to put a cooling water on that packing. And that cooling water comes in and starts in between the packing, if you have 3 or 5 or 6 or whatever, pieces of packing. And that water would go, some would come out onto the ground and some would go into the wet house. So you would dilute your clay or your product. So if it was very critical, they would put a mechanical seal on there, because the mechanical seal, and I wish I had a video on the mechanical seal. The mechanical seal, the face, you have a face here, and then a touching face here, which would be like a tagonite, or mainly tagonite, carbide, tungsten carbide, tagonite. Usually it was 2 different materials, you didn't run the same material together. Well, you would introduce water inside that mechanical seal, and it would actually disperse. The water would come out in a mist. You wouldn't ever, it'd be a vapor. You wouldn't see it. So that would lubricate that seal, but no water would pass through into the wet housing to dilute your product. So probably being Valmir is going to be a new plant, and we'll probably have more mechanical seals than packing, unless engineering has cut costs. And when they holler cut costs, they'll go back to the pump manufacturer and say, hey, how can you save me some money? Well, I can put $200 packing in there and take a $2,000 seal out. So that's a driver, but it's according to the criticality of the product, and if the solids have to stay the same, which one you use. And either one, they work well. Packing is the easiest to replace and repair. You can pull it out, put new in, have it go in about 30 minutes. A seal, you have to pull the pump apart completely. We do have split seals, which are astronomical cost. So, to put on, that you can install one of those in just a short amount of time.
Mechanical seal or stuffing box based mechanism is used for this purpose. Impeller is mounted on bearings, but at suction side of impeller, it is not advisable to fit a bearing, which will block the flow. So bearings have to be fitted at the other end. This means impeller is mounted like a cantilever. For high flow rate pumps,
Sorry to say cantilever. You see, you got the bearing here and the bearing here. And when if y'all back up to that.
for high flow rate pumps, a bearing housing with cooling oil is necessary. This means impeller is not advisable to fit a bearing, since it will block the flow. So,
Okay, when we were showing the cavitation earlier, when that cavitation happens inside that pump, that impeller's sitting in there dancing around. Yeah, I mean, I don't care how short the shaft is. Your best pumps, and we had them several different kinds out there, Chesterton was the name of the company that come out with a pump that was just a short, stubby pump. It was just a little husky looking thing. And the whole idea was the shorter you can make the drive shaft, the better your seals last. You know, that's a fact. So the closer you can get that inboard bearing to that seal, the less deflection you have in the shaft and the impeller, and the longer it will last. Those pumps are very expensive. But I think now, and I'm talking about a long time ago, that's pretty much standard. Is your pumps have the shorter shafts compared to what
Bearings have to be fitted at the other end.
Well, if you see the distance from this bearing, you gotta go pass through your seal and your stuffing box and then to where the impeller is. That's a lot of leverage out there to cause damage to your bearings and stuff. So it's important that pump's sitting there running smooth. If it's sitting there cavitating, interrupting discharge or anything like that, if it's making a noise, that impeller's moving back and forth, that shaft's moving. There's some deflection.
How do you get rid of the cavitation?
So you gotta find out why you're getting air entrainment. Either you're pulling too deep a suction, or you got a little hole in your suction line. You can actually get air entrained through the steel, the stuffing box. And it's usually always on the suction side. Well, it's always on the suction side, it won't go discharge, but, you just got to find where the leak is, where the problem is. And sometimes if the pump is, not sized right for the application, if it's trying to pump too far, or it's pumping too, if you can have too much pump. I mean, you can have more pump than you need.
If you're flowing more out of the discharge than what the pump can take in, then you get cavitation there too.
You're doing the pump a lot of harm. So, proper sizing of the pump, we're not gonna get into it. You have to figure pump curve, you have to figure, discharge, pressure, distance, suction distance, and all that's figured in. That's engineering.
Then you get into friction loss and elbow loss,
Valve loss, pipe, your 90s, valve configuration of the pipe. They were
It gets
bad.
a little confusing.
Yeah, they were bad out there about this. Okay, we got a pump right here. We need to get fluid over the number 9 track. Okay, then take off with that pipe, just go around here and go around this building, and go down here and go up, and then crank the pump up. Why come this pump won't pump? Well, you figured it for 40 foot ahead, but once you add all that pipe to it, there's a formula. I don't know it, but by heart. But there's a formula like when you go so many feet, you got a 90, you got a 45, you got a valve, you got this, that, and the other. And you wind up, you got 200 foot ahead, and you got a pump sitting there for 40 foot. So,
Miller is mounted like a cantilever. For high flow rate pumps, a bearing housing with cooling oil is necessary for improving life of bearings. We thank Turlescar Brothers for their technical support and creation of this video.
yeah, bearing housings, mostly preferred is a bearing housing that has oil in it, like an 80-weight oil, something like that. Those tend to last better if you can keep them clean, but we did have some little Morris pumps out there that still went around with a grease gun and greased the bearing. Well, they were very economic, they were cheap pumps, and they done the job. And we run them for years and years. They're still out there running now. But most preferred is a pump with a bearing housing that's bathed in oil. Back.
Is getting displaced, showing negative pressure will be induced at I.
You see the fluid comes in, and the veins of the impeller, all it does is just slings the fluid out. And once it slings that fluid out into the discharge, it naturally causes a suction, like a straw. But a centrifugal pump, and they didn't explain this here, it's not
Such low
preferred.
pressure helps in
this is not preferred to have the pipe in the tank pulling the suction. First of all, if it's not very close, you're gonna have to prime it. You'll have to have a foot valve on the bottom. Okay, that's another problem. The best configuration, and, well, this is what we have most out of the tank. Tank and pump, right, bottom tank. No problem, until you get trash or something.
Gravitation is most.
Do y'all still have
Yeah.
some type of filter screen in there?
No, we won't, you know, it stay stopped up.
Y'all pumping slurry.
Yeah, slurry, it would stay stopped up. We'd have, oh man, we go in the tank, get hard hats out where there would be there's a mixer in this tank, it's mixing the slurry, it's pumping all the time. And we, that hard hat, what it was doing, what we finally found out after about 2 weeks of trying to troubleshoot this pump, why come it's shut off, they go out there and shut the pump, it wouldn't pump, it quit pumping, they go out there and shut it off, look at it, check it out, crank it back up, it's pump right good for 2 or 3 days. That hard hat would come over here and get in that suction. Stop it, and then when they cut the pump off, the mixer would move it out,
Yeah, and then it come back.
and then it just come around whenever it wanted to.
We had that happen a bunch of times, we'd get,
So somebody dropped a hard
Yeah,
hat
it was
into.
aluminum hard hat, they wasn't, it was supposed to be out there, cause the plastic hard hat floated. So that means they went from then on, when the contractor come out there and had an aluminum hard hat on, they, ooh, you got to take that off.
You got to go.
But, we also found, other things in there. You know, it was unreal what we could get out of one of those tanks. Somebody at night, you know, cocoa balls, Mountain Dew balls, and get in the pump. The weirdest thing we found one time was in the tank, well, the guy done this on purpose. He, it was a dilution tank. The tank had a big old motor up here and a blade come down, that blade was turning like 3,600 RPM, just, it wasn't a mixer, it was a dilution, it was like a blender. You fall over in there, you're gone. Well, he had the idea to put a plastic hard hat in there and take some plastic gloves and blow them up, fill them up with air, and tie them in a knot, and put them in there, and he put a little weight on the bottom of it. You walk by and look at that tank, you saw a hard hat floating around, hands. Yeah, he got in trouble about that. Yeah. I mean, you walk by, you grab it. There's a lot of stuff going on out there. Yeah, this is not a good configuration if you can have it at the bottom. So just keep in mind if you troubleshoot a pump, and it does have the suction just going down in the tank, it's something to look at, you know. It's just not a good situation. A lot of times, and I keep using kaolin plant, well, that's all over new, but, the clay coming up over a period of time, it is 90, will erode it, corrode it, and get a little pinhole in it. You couldn't hardly see it. But, that little pinhole will cause just enough air to go in there and start cavitation, or even cause it to lose suction.
It wouldn't, you wouldn't be able to see.
Yeah, you're hard to see, huh?
Metal magic, because
Yeah.
that's on the suction side, so
Somebody's
it's
trying to
sucking
spray
air
out.
in, you're not getting water out.
Pushing out.
So it wouldn't be spraying
No,
out.
it's
No.
cool.
No, it won't be spraying out. You can't-
So it wouldn't be.
Might see some
Plant
water
these
getting
plant
around.
noise, you can't hear it, it's just a light.
We used to
You
use
can't
that
hear it.
type of suction in Philippines in the Red Sea.
Another thing too,
Put
the
straight in the
pipe,
bottom.
the pipe is put together, the weld, there'll be a weld here, and a weld there, because of the fan, and that weld, the clay will react with that weld, and it'll get a little hole in it. So, this is something I always look at, or even when when somebody welds a pipe, we'll say this is a pipe. When the guy goes around and welds it, well, you see where the weld on the outside? Well, it's also like that on the inside. And after a period of time, that fluid coming up, this part is pretty small on the road, that fluid coming up will cause a vortex or whatever around that weld and eat a little hole through it.
water stream into the system again, and this process continues. This is the reason why priming is important for centrifugal pumps. If no water is present initially, the negative pressure developed by rotating air at eye of impeller will be negligibly small to suck fresh stream of water. Impeller is fitted inside a casing. So the water moving out and will move discharge. Here you can note one specialty of casing.
And we talked about troubleshooting on the suction side. Usually the discharge takes care of itself. Most of your problems when you have a pump is on the suction side. 90% of the time. If it's hard to find the problem, it's usually on the suction side. Discharge will take care of itself. If somebody upstream has closed a valve, surely you're gonna have a sample valve or some type of valve pressure gauge right here, and you're gonna see it's got all kind of pressure. Well, if this don't have suction, it's not gonna have pressure. So, or if there's a leak downstream, somebody be hollering, hey, shut that pump off. So, discharge will take care of itself pretty much when you have pump problems. But 90% of the time, you're probably gonna be on the suction side.
Your main problem if somebody shuts off your valve on the discharge side is if you don't have some type of relief or recirculating type on that pump, the heat builds up and will kill your pump.
It can explode that pump too. Even though it's not considered a positive displacement pump, if you're pumping something like a 80% solid slurry, or something that's dialed, least bit dialed, and that pump's sitting there running and it's not discharging, what it's gonna do is it's gonna beat the water out of it. Well, eventually it'll get hot and start evaporating the water, steaming the water off, and it'll start getting solid. You know, most of the time, your overloads on your motor, check that. But I've seen some cases, we've had them out to explode out there, that these casings are casted. And they're casted out of a cast steel. I mean, it's just Gaysite type steel. And you don't bend them. It's not like a steel that'll bend.
Right.
It's a steel that'll break. So once if it gets up hot and it's too hot on the inside, it'll explode. So that's something to be careful around. We didn't have that problem often. Usually it was a pump that was off in a corner somewhere, nobody walked around it, nobody sees it.
That's what we cracked the casing on one.
Yeah. Another thing to remember, when you screw this impeller on, the impeller is screwed onto the shaft clockwise. All right, and electrician goes out there, all right, you put your pump in, you're all proud of your job, you line it up. You call the electrician, go wire the motor in. And he comes in and wires the motor up backwards. I mean, he has no way to really tell it. It's just two wires apart. You crank it up, and it just spins that impeller off. Well, that impeller's gonna go somewhere. It's gonna come out in front of that pump. It's gonna bust that out. And you've gotta destroy the pump. And we've had brand new ones that happened before. And what happened, the electrician gets called in on the carpet, not the mechanic. But what they started doing was the electrician go out there and make sure it was not coupled. Even if the mechanic has to go back and take the coupling off. He wires the motor up, checks the rotation, then put the coupling on and take off. Another instance we ran into, which y'all probably never will, this pump right here, this is a right-handed vane pump. Well, we didn't know until this instant that they even made a left-handed vane pump. And the reason the vanes were made left-handed was for some way if you put up pumps in series, like one pump to the other one. But anyway, it was long. And we got hold of one of those impellers and put it in a pump that pump from the mine to the plant. And it wouldn't pump. And you pump a little bit, we wouldn't pump much, and they troubleshot that thing a couple of days before they figured out somebody had ordered the wrong, the left-handed main impeller. Only left-handed main impeller I ever seen. And I was out there 30 years. So, even after that incident, something would come up strange, I'd look at that impeller just to make sure. But, that's pretty much it on centrifugal pump. Y'all have some questions. I think you need to know these pumps pretty well. Let's see.
Protecting your.
Watch this cavitation.
Metal erosion is a costly problem. It attacks pumps, valves, piping, and other expensive equipment. No matter what type of liquid is being used, there's always the risk of damage from flashing and cavitation. Wherever there's a restriction in flow, the decrease in pressure can cause a fluid to reach its vapor point. Flashing occurs when the fluid vaporizes and remains a vapor. Metal erosion caused by flashing appears smooth and shiny. Cavitation occurs when the fluid vaporizes, then returns to a liquid state as the pressure increases down the line. The metal damage caused by cavitation is rough and irregular due to pitting of the surface. Cavitation is a major source of damage in control valves and other components. Cavitation occurs as a liquid passes through a restriction, such as a valve. The restriction causes the liquid's velocity to increase and its pressure to decrease. The point of maximum velocity and minimum pressure is called the vena contracta. Vapor bubbles form
Remember that,
when the pressure falls to near the level of the liquid's vapor pressure. When the pressure recovers downstream, the vapor bubbles implode and return to liquid form. After the initial bubble formation and collapse, the bubble may reform and collapse a second time. Liquid microjets form when the recovering pressure makes an indentation in a bubble. Then the microjet bursts through the bubble. These implosions can also cause local pressure waves of up to 100,000 pounds per square inch. The combination of pressure waves and microjets can cause severe damage to the valve blood, seat, and body when they're located near the material surface.
So what all that amounts to is, was talking about, you'll take a valve apart or pump, you'll see pit and everything in it, we'd always, we say, well, there's chemical leaked it up, or, but it won't be wearing out, or when something wears, it's usually smooth, it shines it up, polishes it up, and it wears it away. But this, y'all saw it, earlier, where it's just rough. But it's like the little men running around in there with hammers, just beating and beating and beating. So when you look at it, when you're troubleshooting something, you look at it and say, well, this is cavitation. What's causing this? And how can I stop it? Well, some places, sometimes you can't. It's just the nature of the beast. But sometimes you can stop it by just changing the flow a little bit. A little more flow, a little less flow. A little more volume, a little less volume. I mean, sometimes it's just a little subtle change in it. We had it real bad out there was on float valve was in tank. And the way they do it, that's where those cheap pumps I was telling you come in. You'd have a tank sitting here, a line coming in, a valve right here. We'd have a mechanism with a float down in here. That float would open and close that valve, work the handle on that valve, just like a toilet bowl. So when the level would come up in the tank, it closed that valve back. That was the worst way in the world you could control flow, but it was cheap. That was the way you had to do it. But cause I mean, it started pump had a blocking the discharge on the pump. Pump will sit there and start cavitating. Cavitation will be around this valve, so that valve didn't last long. So you use all the time replacing valve, you know, repairing the wet end of the pump. So they finally come up with VFD, variable frequency drives. And they come into the tank, put what do you call it, transducer, transducer to detect the level in the tank. It goes to VFD, with VFD on the pump, on the motor, on the pump. It would speed up, slow the pump down. That was a lifesaver. That was one of the biggest improvements we made in the plant the whole time I was there, was when we come out with the VFD. So we started saving a lot of equipment. The VFDs were expensive.
Also cause unacceptable noise and vibration that reduce efficiency or lead to loss of process control. Even though cavitation occurs,
Anybody ever been around
it doesn't always
boiler?
cause damage. The extent
You
of
ever heard?
cavitation damage is
I
affected by
heard,
factors.
yeah.
The intensity of
You leave.
pressure increase the potential for damage. The materials used in the construction of the area where the cavitation occurs. Hardened materials reduce damage. The length of exposure to cavitation. The more frequently that cavitation occurs in an area, the more likely it is to sustain damage. Valve size. Increasing the valve size tends to make the effects of cavitation worse. The design of the valve and trim in the area of cavitation. High recovery ball and butterfly valves are more susceptible to cavitation damage. If there is leakage occurring when a valve is closed. Fluid leakage moves fluid from a high pressure area to a low pressure area, which results in cavitation and potential damage. Cavitation damage can be reduced by altering or accommodating any of these factors. Cavitation damage can often be reduced or prevented by using the proper components. Emerson offers these solutions. Valve liners are constructed of hardened materials to protect the valve body. Pressure staging keeps the pressure from falling to near a liquid's vapor pressure, which helps prevent vapor bubbles from forming. Pressure drops are staged by the use of expanding nozzles or expanding flow areas. For example, in the Cavitrol 3 valve trim, nozzles
Yes.
have holes shaped to manage
And
flow
this is
separation.
more trying to sell you that valve. Okay, we wanna do your test now, take a break and do your test. Right?
Sometimes packing material is used to seal around the shaft, but most equipment that uses packing requires a small amount of leak-off to reduce friction between the packing and the shaft. So in applications where leakage needs to be prevented, mechanical seals are often used. As a mechanic, you'll need to understand how mechanical seals work and how they're installed. Mechanical seals are often used in applications where leakage around a shaft needs to be prevented. For example, they're often used on pumps that handle hazardous fluids. Mechanical seals can be divided into two basic categories: pusher type and non-pusher type. These categories are based on the ways in which the seals allow the rotating ring and the seal between the ring and the shaft to move along the shaft so that proper clearances are maintained. Although mechanical seals are designed to last a long time, some of them fail well before their life expectancy is reached. One of the most common causes of seal failure involves problems with the equipment that the seal is installed on. For example, misaligned shafts, bent shafts, or bad bearings could easily cause a mechanical seal to fail. Sometimes, however, mechanical seals fail for other reasons. Another way that the seal face gap can widen is if either seal face becomes distorted or warped. One cause of seal face distortion is over-tightening the gland bolts during installation. Another cause of seal failures is overheating. Heat is often a part of a machine's operation, and mechanical seals are designed to function under those conditions. But sometimes the heat becomes so severe that the seal parts begin to break down. The seal faces may also be attacked by the fluid that's being sealed. One way to tell if this has happened is by examining the seal faces for damage. The materials used to make the seal faces are generally corrosion resistant, so corroded or pitted seal faces could indicate a chemical incompatibility problem. Another cause of seal failures involves the improper installation of the seal.
Let's try this.
One of
I haven't viewed these, it's on better.
Remains clean and hygienic. Some 7 are to be seen. And low speeds. This is what a mechanical seal looks like.
It works about there.
But how does it work?
Scratch your head.
A housing and a shaft. Fluid is stirred, pumped, centrifuged, or treated in some other way within the housing. It's the shaft that initiates the rotary motion.
What is he doing?
The gap between the housing and the shaft has to be sealed. That's obvious.
Duct tape.
Now the shaft will no longer turn. Rotation and sealing. Can they ever be compatible? Here, the shaft requires clearance so that it can rotate. Seal faces not parallel with, but rather perpendicular to the axis. That's the answer. The housing and the shaft boss form the seal faces. Good support is essential for the proper performance of the seal. But will the seal withstand higher loads? The seal starts leaking due to wear caused by friction.
Really good.
The shaft and housing are far too expensive to be used as wearing parts. Ideally, only the seal faces should be changed. A stationary seat at the housing, a seal face on the shaft. Exchangeable wearing parts make it possible to optimize the various available materials. Here, the seal is perfect. But here and here, we still have a leakage path. Of course, instead of one sealing gap, there are now 3. No wonder there's a drip. Because seal and seal face rotate at the same speed, they don't move in relation to each other. Between the housing and the stationary seal face, there is also no movement. And if nothing moves, sealing is no problem. secondary seals are used.
See how this works, the seal runs. Kind of silly, it's about as good as an illustration, I was
In relation to each other. Between the housing and the stationary seal face, there is also no movement. And if nothing moves, sealing is no problem. Secondary seals are used.
They're just sealing it to the shaft. This movable seal phase, which I said earlier would be something like a tagonite or carbide, tungsten carbide, or whatever type of phase it is. And this, that seals that to the shaft, and this seals that to the housing. You're movable when you're stationary.
Yeah, that's my
Lunch break already.
Wear cannot be totally excluded, but it can be compensated.
Spring.
With a spring, for example, which presses the sealing face to the stationary seat. Here we have it, the mechanical seal with its 5 components.
And what I was talking about earlier, when we brought up on the board, you put water in,
Still inefficient.
it'll have a channel in here where water can come in and get between these two faces to cool it off. With the water, the centrifugal force of the shaft to send the water out. And it's very slight pressure you put on the water. You don't have very much pressure on it, but it's just as long as there's a little bit of moisture on those two seal faces, it'll be fine to keep it cool and it'll seal.
Rotating seal face with secondary seal and spring. Stationary seat with secondary seal. Two rules must be observed to enable this principle to function. Even finely ground surfaces still have a certain degree of roughness. This roughness must be particularly small on surfaces that slide against each other. Consequently, stationary and rotating seal faces are not only ground, they are also lapped. Lapping gives the seal faces a higher bearing surface, thereby increasing the load capacity of the seal. The sliding faces must be absolutely flat and smooth with a mirror finish. That is the first rule. The second rule is
Wow.
the sliding surfaces must be perpendicular to the shaft axis. All this requires strict adherence to the permissible parallel run-out tolerance, stable shaft bearing support, and careful assembly. Flatness and negligible surface roughness of the sliding faces are preconditions for minimal spacing between the seal faces, for the microscopically small sealing gap. Sealing gap? Sealing gap? A gap would fill up with fluid. A gap must surely result in leakage. Wait a moment. The seal face is slide on a thin fluid film. This fluid film is hair thin, so that the sliding faces hardly come into contact with each other. The fluid that is to be sealed simultaneously supplies the lubricating film for an optimal sliding motion of the seal faces. That's the answer.
And what food do you have?
Seen that?
The sealing effect is either
Let the smoke
100%,
out.
but then the seal faces will run dry and wear, or there's a lubricating film between the seal faces and minimal leakage will be unavoidable. But then, a seal with a very low leakage rate will offer long service life and utmost reliability. This means the lubricating film is indispensable for the performance of a mechanical seal. It can be quite a problem for the lubricating film to maintain the balance, to remain stable, as there are several factors in practical operation that influence the stability of the lubricating film. The medium, pressure difference between inside and outside, high and low temperatures, high and extremely high speeds. The large number of different mechanical seal designs matches the influencing factors and their numerous combinations. Whether it's a specially designed or mass-produced mechanical seal, the range of application is indeed very wide. For shaft diameters between 5 and 500 millimeters. Sealing pressures from vacuum to pressures of 45 megapascals. Temperatures from -200 to +450 degrees centigrade. For sliding velocities of up to 150 meters per second. Mechanical seals from Volkmann.
It was silly, but a pretty good installation, illustration of how mechanical seal works. All right, here's, we had these out of plant, Chesterton, 442 split mechanical seal. Let's see how that is.
The Chesterton 442 split mechanical seal is designed for
Very expensive seal. They start at like $2,500 for a small one.
25.
Well, that would've been a regular seal, probably a split seal about 35.
Yeah, but would they last longer than the regular seals on the average?
If you put it in right.
So if you take the time to put it in right, you're gonna save costs in the long run.
Yeah.
I mean, it's
Well,
not.
it was, a lot of times when the seal went bad in one, probably done contaminated bearing housing a little bit, so. They kind of looked at it, when the seal go bad, they pull the whole pump out, rebuild a pump, put a new pump, another pump in with a new seal. You know, sometimes we just change the seal. But in critical applications, we did use this mechanical seal here. Like I say, if it was installed correctly, it'd last just as long as the regular.
the easiest and most reliable installation of any split mechanical seal. By following the simple steps covered in the seal.
Especially this application right here. You notice this pump?
By following the simple.
That's pump is usually used, and the name of that type of is slipped my mind. The impellers in here. And it actually has a bearing here and a bearing here, so it has two seals. That pump pumps high pressure, a lot of times it pumps steam. So, yeah, this would be the type pump that, because of the bearing located right there and right there, if, you change the seal out and go to regular seal, it's just a major job, major operation, because you just have to tear that pump all to pieces. And that situation probably split seal, that's what he's gonna put on.
Install the 442 in your equipment. Before you remove the parts from the carton, prepare a clean work surface and make sure your hands are clean.
Chesterton is one I was telling you about, that come out with a short pump,
Free from any contaminants.
short shaft, lasting so well, real good pump, very expensive.
Installation accessories such as X-keys, silicone grease, and installation instructions are also included for ease of it can follow the same.
What was the little yellow things
Mechanical
there?
seal reliability and
What were those little yellow
performance.
pieces?
That's setting tabs,
Installation accessories such as X-keys, silicone grease, and
when you put it together, you have this tab that hold it in place, and you tighten both tabs and pull the tab out.
before you begin the installation, be sure to read the instructions so you can follow the simple steps as described. Rotating equipment in good operating condition is essential to mechanical seal reliability and performance.
All right,
Make sure
he's
your
checking
equipment
runout
meets the
right there,
equipment
that's,
parameters outlined in the installation.
So,
Make sure your
keep
equipment
talking
meets
more.
the equipment parameters.
he's put a dial indicator on that shaft, check runout, and that'll tell you got a bad bearing or bad shaft. But he's got, I don't know what the tolerance is on one of those seals, probably about 4 thousandths. He's got 7,000 to 8,000 runout, and he pulled the pump out, and we just put that seal in there, because he's gonna tear it up real quick, so the shaft's sitting there moving back forward. So he's checking to see the straightness of that shaft.
Stability and performance. Make sure your equipment meets the equipment parameters outlined in the installation instructions. Begin by disengaging the 2 socket head cap screws from the gland. With the gland on the work surface and the springs facing up, separate the gland halves. Make sure you remove all packaging material in the gland halves. You now have access to the rotary holder. Disengage the 2 socket head cap screws from the rotary holder and place the halves on the clean work surface. Take the stationary and rotary seal faces out of their packaging.
We're not gonna go through all that.
Work surface.
And y'all can tell them that.
Pull the ball and socket joints, such as the stationary and rotary O-rings, by carefully pulling in the O-ring seam. The rotary O-ring is slightly longer than the stationary O-ring and is marked with a purple dot for identification. Lubricate the rotary holder gaskets and O-ring with the silicone grease included. Make sure they are properly seated in their grooves. Grease the gland joint gaskets. Make sure they are also properly seated in the gland grooves. Begin the assembly by placing the rotary holder halves around the shaft. There are 2 methods to properly set the rotary holder to the shaft.
What he said, what was that YPC had on top, what he said was?
What's that now?
What was that,
What was the Y piece?
the YPC had a hole in the bearing, what was that called?
Oh, I wouldn't, looking at these other.
It was like a feeler gauge, but it wasn't a feeler gauge, it was shaped like a Y very thin.
I'd have to go back and find
That's fine, I can look it up.
May show you right here.
Sealing. Mechanical seal failure. All mechanical seals will eventually wear out, but some of these seals will last years, while others will fail prematurely. What causes or factors are involved in determining the eventual life of a seal? What
Hold on.
are some of the root causes of mechanical?
What happened, I see a video I wanna show you, and I see another one, I'll show you that one, and it changes over here, and don't go back to the original.
Centrifugal pumps are the most preferred pumping devices in the hydraulic world. In this video, We will have a conceptual overview of
Rotary pump, this is just the gear pump we showed you earlier.
Rotary pumps.
Rotary
There are
pumps.
4 types of rotary pumps: screw pump, gear pump, lobe pump,
We use the load
vane pump.
and vane pump.
I thought you were saying load while there was load.
Load.
In screw pumps, it is the intermeshing of the threads on the rotors and the close fit of the surrounding housing that creates one or more sets of moving seals in a series between the pump inlet and outlet.
Compressors have
These
pumps
sets
like
of
this.
seals or locks, as they are sometimes
You don't see them common anymore. You had piston compressors, boo, 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 on the piston cords and compressor, and then they had the rotary screw pump compressor, which is built something like this. And your Solaire compressors, or their pumps are built something like this. They're very efficient and quiet. They, really good pumps for air.
referred to, act as a labyrinth and provide the screw pump with its positive pressure capability. The successive sets of seals form fully enclosed cavities that move continuously from inlet to outlet. These cavities trap liquid at the inlet and carry it along to the outlet, providing a smooth flow. The pump is so named
That pump and a compressor, and if y'all have been around a compressor with pistons, you know, you get a puff of air. That's a steady flow of air. These pumps are great for when it's like sandblasting or running a plant, you know, where you gotta have a steady flow of air, and the pressure can't range up and down. You need just a steady flow, so that's why that design is preferred.
because it has 2 gears that are side by side or external to each other. A drive gear that is driven by a motor rotates an idler gear in the opposite direction. When the gears rotate, the liquid, which is trapped in the gear teeth spaces between the housing bow and the outside of the gears, is transferred from the inlet side of the pump to the outlet side of the pump. The meshing of the gears on the discharge side of the pump forces the liquid out of the pump and into the discharge piping. The lobe pump receives its name from the rounded shape of the rotor radial surfaces that
This
permits
pump
the
here, we
rotors
had-
to be continuously in contact
we
with
use a
each
lot of
other
these.
as they rotate.
Rotary load pumps, like a lot of times these loads will be rubber. Where they just last long, made out of neoprene or rubber or UHNW type material. Those were tough pumps. They would pump real dialed material and real thick stuff. They use those in the mine where the kale would come out straight out of the ground and mixed with a little water. It was nasty.
Lobe pumps can be either single or multiple lobe pumps and carry fluid between their rotor lobes,
Works
much
like
in the
with gear
same way
pump.
as a gear pump
Just
does.
have a bigger cavity.
Unlike gear pumps, however, neither the number of lobes nor their shape permits one rotor to drive the other. And so all true lobe pumps
Good thing about these
require
pumps
tiny
too, the operator
gears.
didn't close the valve on them one time. He went down there and closed the valve on it, he knew it, so they'd blow it out. It was gonna blow out something.
I would think they would last longer because of less gear wear.
What's that now?
I would think they would last longer too because of less gear wear.
Yeah, those pumps lasted, they'd run.
Vane pump includes a rotating cylinder containing
But now,
equally
this,
spaced
unlike the
braided
gear
pistons,
pump,
a
let me
ring,
go back. Unlike the gear pump, the low pump, I think it's called, it's connected in the back. These gears, they're connected together. This load does not run that one. They're connected with gears in the outside of the pump. So unlike the gear pump where you got the rotating gear and stationary well, one is turning the other, this don't, that's not the case, so that's why you got double
You gotta-
power.
So basically, that's separate drives then.
Yeah,
You got
right
to
back
drive
there,
gears
it's not
behind it.
short.
But
It shows it
these
briefly.
right here, they're still
Did it-
coming in contact, aren't they, to keep the water from going in each one of them?
Yes.
Yeah, they have to touch. They
Then you're
come,
gonna have a synchronicity
Right,
issue with
right.
it.
yeah, you gotta have those things, they gotta be synchronized.
Right at the end of this video, it showed,
To radial surfaces,
about the end of this part of the video,
to
it
be
showed the gear
continuously in
drive briefly
contact
at the
with
back.
each other as they rotate. Lobe pumps can be either single or multiple lobe pumps and carry fluid between their rotor lobes much in the same way as a gear pump does. Unlike gear pumps, however, neither the number of lobes nor their shape permits one rotor to drive the other, and so all true lobe pumps require timing gears.
Yeah, so you saw the gears in the back, and that's how those look.
Vane pump includes a rotating cylinder containing equally spaced radial pistons arranged radially around the
You didn't want
cylinder
these
center
around
line. A spring pushes the pistons against
They
the
were
inner
used for
surface
chemicals.
of an encircling stationary ring mounted eccentric to the cylinder. The pistons draw in fluid
Wouldn't you have a
during
lot of
half
wear
the
on those
revolution
vanes because of that?
and drive fluid out during the other half.
Say again,
Wouldn't you have a lot of wear on the vanes because of the way
Yeah,
it's
yeah.
working?
if you put any kind of, corrosive, anything in there, kaolin or anything like that.
Well, true, but I'm also looking at the friction way the vanes are
Yeah.
sliding against the housing.
But, they were used for some chemicals out there, and they were good for what they're built for.
The greater the ring eccentricity is, the longer the piston stroke and more fluid they transfer. Applications of rotary pumps are: gear pumps handle more viscous fluids. The sliding vane pump suits both viscous and non-viscous fluids.
What is this?
Sliding vane pumps cannot handle dirty or gritty
Viscosity.
liquids.
Thickness,
Vane pumps are ideally
high
suited
flows.
for low viscosity, non-lubricating
Molasses are very
liquids.
viscous. Water is not.
Sliding vane pumps are used for vacuum services. Load pumps are used for food and beverage processing. Load pumps can handle both low and high viscosity fluids.
That's pretty good there. Here's another one. What do they do? I don't know what they do. She didn't talk about it. Rotary vane pump. Just trying to sell you a pump. That's that's a rotary vane pump, it was, there you go. Show you how it operates. Hydraulic pumps is built something like that.
picture.
Gentlemen, welcome back to the shop, and I dare say, the odd lady. Because if you're checking out a VJO about a hydraulic gear pump, chances are you can roll your own smigarettes and kickstart a Harley. My hat's off to you. As such, I trust you will not be offended by a couple of F-bombs and the odd dick joke.
Yeah, we might.
Let's go with that one.
Gear
We
pump.
all grown up. Yeah.
Oh, he's on.
We're on some knowledge.
Glad he gave you a warning. Probably a good video too.
Yeah. Probably the best one. Look out at the house. Remember that one.
Somebody click on view and walk out the door.
Gentlemen, welcome back to the shop. We cleaned off the healing bench here in order to autopsy another unwilling victim. This one is something special. These are crawl sensors, hydraulic industrial automation, big ticket items made in Österreich, land of the Durdle. Anyway, those things.
This one might be in trouble.
I might subscribe.
My long voice easy.
Far away from home. The mechanic. Oh, really?
There you go, Brad.
Whoa!
Oh my gosh, that looks like Josh.
Centrifugal pumps are the most preferred pumping devices in the
Plants use many
Trying to find a stage pump. There we go.
What? That's liquids. One of the most common types of pumps in use today is a centrifugal pump. A centrifugal pump
I'm just gonna show you this. Anybody got deep well at home? Pump in it? Your pump looks something like that.
The submersible pumps?
Yeah, something like this now. And if I could pull up, maybe just pull up a well pump. But anyway, this, you got 1, 2, 3, 4, 5, 6 impellers. It's a 6-stage pump. One impeller pumps to the other one, 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 to the house. So, what do the standard well pump have? About 3 impellers in it? A 3-stage pump, is that what it is? 3-stage. So you have 3 impellers, little bitty impellers in there. The first one just pumps to the next one and to the next one, and it's where it can, it's just create pressure and, head, so we can get it from 100 miles, all the way to 160 foot, I think. That's a long way to pump water.
Got 465.
Yeah.
So yeah, you gotta have constant head.
Yeah, so, yeah, some of them need, like I say, 460, they get on down there. That's what you need to pump. Water out of your
uses
well.
one or more impellers to create a centrifugal force that pushes the processed liquid through the pump. While there are a number of different types of centrifugal pumps, they can be grouped into 2 basic categories: single-stage pumps and multi-stage pumps. Centrifugal pumps use centrifugal force to move liquids. Centrifugal force is the force that exists when an object or material moves in a circular motion. This force causes the object or material to move outward, away from the center of rotation. In a centrifugal pump, what moves outward is the process liquid. We can see how a centrifugal pump works by using this simplified illustration.
I just wanted you to see
All
that vein.
centrifugal pumps have an inlet, a casing, and an outlet. Inside the pump's casing is an impeller. It has a series of curved vanes that extend out from its center. The pump's casing is designed so that the area around the impeller creates
this is what they call a jet pump, well pump. Shower well. I had one of these for years.
You have to prime that.
Yeah.
All
Walk in the house,
shallow jet pumps require
ask the wife, if you've been washing clothes, can I take a shower? So we had it, yeah, so if she just got through washing clothes, I needed to wait an hour or 30 minutes, an hour for the well to come back up. That was really good. We've done that for about 10 years. And, bought a swimming pool, a battleground swimming pool, which is no longer there. Thank the Lord. But anyway, I went to fill that pool up and I was like, man, it's gonna take 6 months to fill this pool up. But I'm just gonna have to let it trickle in there, cause my well just wouldn't do it. So I was gonna run water hoses from my sister's house across the road, which had a never ending well, water supply. And my wife said, ain't it about time to put in a well? I said, yeah, I guess so. But anyway, they come to the house and we got from, my 50-foot well that I had been using for years, 10 years, got right next to it, went down 160 foot, got 150 gallons a minute. I'm talking about they hit like, he said we get underground river. So I got plenty of water, but it's got, I got one of those filters on my well, get the metal out, iron. It was turning the toilet rusty and everything, but I had plenty of water. But,
That's the kind of pump we use for irrigation up at the lake.
Yeah.
Pump out of the lake.
Pump out of the lake, jet pump.
And if you lose, if something happens and you lose the prime on the pump, it's not a good thing.
Yeah.
It'll burn it up.
for priming prior to use.
You won't see hardly any of these out of the plant, except for maybe a little application here to pump out a little salt or
Remove the
something like
priming
that.
flood, and using a funnel and a jug of water,
Very good
fill the
pumps.
pump head completely. This will
Well,
take
what they do
close
is
to
they
a
pump.
half gallon of liquid. The liquid allows the pump to prime and also lubricates the seal that protects the wet end of the pump from the electrical end of the pump.
Okay.
This pump always needs to be
You'll have
full of
enough
water
fun one day?
prior to use.
He's still there.
Once the pump bed is completely full,
I've done that a million times.
replace the priming plug,
If you let the pump run out, then it loses prime.
tighten
You
and
kept
secure.
jugs, I did, I kept
Most
literally
shales
kept
need to
jugs
put
out
that.
there in the pump house. Prime, because we can run out of water.
That's our work problem up there at the lake. Most
Flint
of
and
them
check
get
valves
in
are
the foot
important
valve.
accessories in
Yeah,
a
the foot valve
shallow
won't work.
jet pump application.
That was a happy day when I covered that well, though.
Install.
It was a happy day.
Actually had a guy over in Congress come in the old open well. We had to go get him out one night. When I went in the fire department. It was lucky there was water there. The water broke his fall a little bit.
Yeah.
How's the thing down there at Clack? Still back, still working tonight?
Monday, we're gonna go back to,
What got me down there?
chapter 9.
Saturday,
Hey, they might change my mind.
Don't do that.
How about that?
You got these up.
So you leave about 6 every day? Come back down here, get
No,
yourself? In the morning.
Okay.
Black and chicken. Hang in there.
Thanks, Frank. See you tomorrow. Mr. Noah.
You taking notes, if you know. You got it recorded? Yeah, he recorded.